Okay, last segment of the longest chapter in the history of mankind, right here. 2 more slides. So what you'll be asked to do on the AP exam is to talk about the interrelationship between alpha and beta. When alpha gets bigger, beta gets smaller, and vice versa. The way to make them both smaller is to increase your sample size. So sort of those big idea things. And the other thing is to interpret errors in the context of a real world problem. So something like this one. So we have these highway safety engineers who test some new road signs, hoping that increased reflectivity will make them more visible to drivers. Volunteers drive through a test course with several of the old and new style signs and rate which signs show up the best. So, probably they've disguised which ones are which. They've got them all randomized and people rate. What would a type 1 error be? Okay, so in general, kind of get my thoughts together. In general, for a type 1 error, the null is true, but we make a mistake and reject it. Okay, so what does it mean for the null to be true here? Well, the null hypothesis is that nothing interesting is going on, which means the old signs and the new signs show up equally well, so they'd be rated about the same. So the old and new signs are equally visible. So that's the true null in context. But by rejecting it, we think the new ones are better. So, but we think that the new signs are better. Now, just to kind of expand this to one more thought, the cost of this error would be that we think we've got some good new signs. So we're probably going to spend some money replacing old signs with new ones, but they don't really work better. So we've thrown money down the drain to put new signs up that really aren't more helpful than what we had before. Okay, on the other hand, if we commit a type 2 error, what would that be? So in a type 2 error situation, the null is false, but we fail to reject it. So in context, if the null is false, it means the new signs really are better than the old signs. So the new signs really are better than the old signs. But we don't think they are. So the sample that we took with these volunteers indicated that the new ones weren't better than the old ones, but in reality they are. So I just had a bad sample and I made a mistake. The consequence of this type of error would be that we have the ability to improve road signs and make driving safer, but we don't do it because we didn't think they really worked. In this context, what is meant by the power of the test? So power of the test is the probability of having a false null and rejecting it. So making a correct decision. So it is the probability, if I can spell, of correctly deciding that the new signs are better. Because if the null is false, the signs aren't the same, the new ones are better, and if we reject the null, then we've correctly identified that they are better. Last but not least, if the hypothesis is tested at the 1% level of significance, so that's alpha level of 0.01 instead of an alpha level of 0.05, how will it affect the power? So if I go back to the pictures, power is what I get when I correctly diagnose a false hypothesis, correctly reject a false hypothesis. If I increase my significance level, that means I have more area in which to do a rejection. So 5% of the samples will be reject zone instead of 1%. So if I have a better chance of rejecting a null, then I have a better chance at power. So the power will increase because I'm more likely to reject the null hypothesis, which means I'm more likely to reject the false one. Power would also increase if we increase the sample size, because if our sample size is bigger, we're more likely to make a correct decision. And power is a correct decision. All right, that's it. Homework is all on Schoology, so go forth and practice.